that is the agenda for today. I will start with a little bit overview of the architecture of what I had to find the name. So I call Pragmatic Data Platform in my book. Then some example of the automation of that ingestion and storage can be done. So these I will show first with the slides. Then when we finish, for the time we still have, we can browse one of my pet projects. So if you have questions, we can go a little bit more deep. Then I will talk in the second part of the presentation about organize the refine layer, because in the end, I think that the ingestion storage should be pretty much a given, while the future and where I would really like that we all push to improve and organize better the refine layer, and then maybe how we deliver the data. Last but not least, a little bit of talking about master data, data domains, and data mesh, because I think it's a kind of a natural extension, at least in maybe soft mesh, compared to the full mesh and totally different system with different technologies that might be out of reach of most common organizations. A softer mesh where we divide the data projects according to the organization is probably easier and in reach of most organizations. So to get started, as I said, it's quite long that I've been writing code. And in the last 10, 15 years, I've been often asked, how can we improve our data projects? That's quite common. And coming from software engineering and having seen the switch in software engineering from a lot of manual work to DevOps, automated testing, and so on, I've been often say that, okay, this is what we have to do, but it was difficult. Then DBT came along, and it made a lot of the tooling used in in software engineering available also for data engineering. And so now what I see that is still missing is the competence or knowledge from a lot of the data people. So people that is writing SQL most of the time, they have not a software engineering background. They don't know what clean code is. They are fine to write a 500 lines piece of SQL with a lot of nested subqueries, and that's fine for them. Unfortunately, this is not really maintained. So this is what I say with the from art to industry. So we know from software engineering that there are better ways of doing, that clean code matters. So we don't have to invent the wheel every time that a new data platform is created. We have some good practice, some organizational pattern that we can use. For example, Data Vault, I think, has done a great job in that direction. So the idea is invent a little bit less, rely more on best practice, and do things in a repeatable way. Pretty much the different from an artisan that does something pretty much with a lot of freedom, a lot of skill, but you need a lot of skill to have a good result, to an industry where the practices, the way of working drives even less skilled people to produce still very good, reliable results. So this, at eye level, it is the, I would say, very common architectures that you're probably used to. So if you say this is nothing new, nothing strange, that's perfectly right. So on the left, we have a lot of sources, and with time, we will probably get even more. Then we have a data storage layer where we have landing table that where we get what we have in files or what is pushed in real time or near real time. Then we have to adapt this data, because often what we get is not very easy to use. And adapt, I really mean not changing, no semantic changes, just make it usable. So you have a date as a piece of text that's not very usable. You can parse it as a proper date, even a timestamp. You might want to convert it to UTC. So no change in the meaning, no change in the semantic. You have obscure code for this row is deleted. You want to make maybe is deleted Boolean column. That's fine. That's not changing the semantic. It's just making the data usable. And of course, you also have to decide or to explicit what are the keys and what a change means. So what are the columns that create a new version for that object? Once we have that, we want just to store everything that comes in, so all the historical data. So this is pretty much very similar to what if you know Data Vault, it's pretty much the same as Data Vault. You ingest all the changing data. In Data Vault, you have the satellite that stores it and the hub that has the key. Here, I just keep them together. So, but for 99% of what I'm going to talk today, Data Vault, Pragmatic Data Platform, you can do it both ways. They both work in very similar way. And a lot of the benefits are the same. The big difference is everybody understands a single table with keys and data, but if you have experienced people that knows about Data Vault, you can also use hub, sat, links, and all the other things from Data Vault. Then, and I think here it's very important, we have put their storage. We have built a very solid base. Then we have the big task of making that data into information. So we will gonna build a refined layer where we refine the data, where we build the business concepts. To do that, most often than not, you also need some master data and some master data mapping, because if you have different systems, they might not use the same keys. So you have to make things compatible. And then finally, you have to deliver this data for different use cases. And I see as a very good practice to try to define different data marts for the different use case, so that, again, software engineer, we try to keep the interface as small as it is possible for each there. And also you can easily control who has access to what. And I think that probably the feature that, as a developer, I love most is the fact that by dividing the irreplaceable state in the data storage layer, everything else does not have state that we have to keep. So we can rebuild everything at will. We can use incremental models, that of course is a type of state, but we can also rebuild table from scratch. So this makes everything in refined layer and in data marts much easier to update, much easier to correct. Everything becomes much more agile. So you can forget about having to backfill your tables, because you had incremental calculation that you could not change. So you had to do a complex calculation. You had to even sometimes reverse engineer how was the data before the wrong rule to apply the correct one. So that's now you don't have to do anymore. If we delve a little bit in the detail of each of these steps, as data sources, nowadays the common platform like Snowflake, I thought when I say data platform, I'm referring to something like Snowflake, Databricks, BigQuery, so the cloud platform that pretty much offer almost all the same abilities. So you can easily ingest data from files. All of these platforms make it very simple. You can also use some software as a service tools like Fivetran, Supermatrix, a few others. So there is quite a lot of this that can take the data from your less structured or complex APIs, like, I don't know, Google Analytics or some other operational systems, and deliver directly into a landing table in your data warehouse. So whichever way you choose, moving data is nowadays not a complicated step at all. When we come to the ingestion and historicization, this also, I consider this a solved problem. So you have ways to do it. We have seen Data Vault do it quite well. I prefer a simpler approach, because most of the project where I work, I don't have people trained for Data Vault. So it would make them complicate our delivery if we had to train a lot of people that don't care to learn Data Vault. So what we do is that we have this landing table that pretty much are as the same as the files, just loaded into the data platform so that the access is much easier and much quicker. We have this staging table where we do this adaptation, the history model, that is where we actually store the different version of each entity. And you see, it is one source entity to one landing table, to one staging, to one history. This is the typical case. 99% of the time is like that. Sometimes, if you have legacy systems where you don't have the individual entities out, you just have a big document that has inside a lot of entities. So then you will probably have a single landing table and you will have two or three things coming out. For example, we can see after in my pet example, in my pet project, my broker provides me open position and securities inside. I don't get a security data feed. I just get everything inside the same document. But of course, the granularity of the two is different. So if you are lucky and you just get, like you nowadays we get most of the time, export from the original databases, from operational database. You get one table by one. That's simple. It's all a straight pipeline. Otherwise, you might have that from one landing table you get two or three pipelines. Never join them. That's, I think, it's important. Saving the history of something that you join, it's going to be mayhem. It's going to be very complicated. So please don't. In Finland, they say, don't take the blood out of your own nose. So that's a good advice, I think. And lastly, after that, we have saved the history and we do it in insert only way so that we are very efficient. So we exploit the best of this cloud platform. Then I suggest that you also build this version or SCD that pretty much use the ingestion metadata to provide you a nice, easy to use interface where you have the version, the validity from to, you have a stable ID that points to the exact version because the ID of the entity will point to all the version of one entity. But if you want to use slowly changing dimension, you need to point to the specific version in your facts. And so this is, you will see, it's built through very simple markers. You have to put some of your brain in the staging layer, because of course there you have to choose names, you have to know what you want to do with this data to make it more usable, you have to declare what is the hash key, and if you know Data Vault, you see that hash key is the same concept. So what is the identity of this entity? You have to declare a hash diff, that is what is a new version. So these things are the only thing that you really have to know. And you see, it's not business concepts, it's actual structure of the entities that you are storing. Then when we move to the data refinement layer, this is what we don't want to have. This is what I have found way too many times. And I hope that you agree that this kind of spaghetti mix is not really what we want to have. So the idea, and I think that the DBT in itself is helping a lot in making this simpler because it throws you to work in a modular way. So this is what we're trying to build, something that has a structure. This is something that unfortunately we can't say how it's going to be. Every project is going to be different. Every business, even in the same industry, has its own peculiarities. So this is what makes pretty much every data platform unique. But we will see in the next slide that there is some structure that we can try to have. And as always, order, good practices, conventions to be followed, they help people to not get lost. They help people to know what they're doing. And so this is where we are trying. This is where the battle is. And so this is what I'm trying to also collect good ways of doing. And then finally, for the data delivery, in the end, we are free to deliver the data as our clients need. So the typical is using Kimball star schema. So you will probably do some data marts that deliver facts and dimensions. In many cases, especially nowadays with AI, machine learning, or some reporting tool, prefer to have actually wide table where you have already pre-joined the facts and some dimensions. So that is perfectly fine. So for DBT, it's not a problem. It's just SQL. And in many cases, especially if you have large volumes, you don't really want to deliver just a table that they have to query to a JDBC connection or some connection. In the end, the most effective way to move data across clouds or in big quantity is still files. So another thing that I see commonly done is that you can actually build a data mart that represents the data that you are going to provide, but in the end, what you do is that you save these as files in some cloud provider. So if we do a recap of the first step, so this is really all the important points. So in the ingestion, we load the data as it is. And the key fact is that this is the starting of our technical timeline. The most important thing for us to know is that, okay, when the data platform got some information. So whether you call it ingestion timestamp, load timestamp, if you come more from Data Vault, in the end, the important thing is that this is easy to do and provide an accurate ingestion timestamp. Then, of course, there is also other important metadata like the record source and other pieces of information that if we want and if we have, it makes sense to store, and you will see that I tend to do it. But the most important, the only really essential, I would say ingestion timestamp, and almost as essential, the record source, where the data is coming from. Then in the staging, that's where you know what you have to do. I can say only so much. So definitely good names, because if you are used to SAP, they have horrible column names. So what you will get out of SAP is something that even if I have worked with that, 3 months later, I will not remember what a column means. They have horrible codes. So please don't let these things go beyond the first step. Help your colleagues, use decent names. Then all the other adaptation, all the other hard rules, how you want your data to be. And then define the key and the hash key and the hash diff. Lastly, we ingest with insert only. And you can decide also according to how much need for audit ability. You can decide how you do your ingestion. So in the simplest way, you just care about the latest version. That helps in a lot of ways. But of course, if you reload the table, you will lose a lot of history. So that's what you typically don't want to do. But in some cases, this is good enough. In general, what I prefer to do is that because it costs almost nothing, the performance is almost the same, you just have to provide a little bit more metadata, is load all the version that you see in your inputs, even if you get more than one change in a single ingestion. That makes your load more robust, that makes your data more usable, and you could also explain much better what is happening on your source platform, that you might not have the same level of observability on the data that is in your source platform, and also what you have been seeing in the end of your data warehouse, because there you will have all the changes that you have recorded, that you have received. And then, of course, in some industry more than others, it's also important to deal with the temporality. So one thing is when we got it, and another thing when these things become real in the real world, when this thing takes effort. And last but not least, the utility SCD. I have not really fully decided what the best name is. So if you have ideas, SCD is slowly changing dimension. but that works perfectly well, but only for dimension. Version is more general and also explain that some facts that are mutable, they have versions, and you just, with the fact, you just want to have the last one in general. You keep the old one for analysis, but you generally don't want to sum three versions of the order. You just want the last one. And so version to me is more general. SCD, I think it's very clear for people who know what is slow changing dimension is. In the end, you can name them as you like. If you're curious, these a few slides that show how simple it can be, because this is what I mean. So this part, it's all pattern driven. It should be as simple as possible, and you should really spend no time, if not in the part in the staging where you decide something. So setting up a new ingestion, pretty much you have to say in which database you want to load, in which schema, and the file format you are reading from. And in Snowflake, for example, you use a stage to connect to your files. So you have to define these four things, and you define generally once per source system. Once you have defined that, and you can do that in a more readable YAML-based way, or you can, if you are more of a coder, you can do that as a macro with a function that returns the code and the name, or the name. And then you have to ingest the individual files, individual entities. And to do that, it's even simpler. You have to say which files you want to ingest. You see number one, what is the name of the landing table, and then the list of columns. If you don't say anything, they get ingested as text. But if you also, because sometimes you can't ingest with the proper data type since the beginning. In this case, my broker, as I have multiple accounts, for each account, they repeat the header. So in the middle of the data that I get also a text, a row that is full text, is always text. So I have to ingest everything as text, remove those lines, and then I can, in the staging layer, I will have to provide the right data types. And then how complex it is, this staging layer? It should be also that should be very simple. So again, you see, first thing, where do we get the data? Well, you get the data from the landing table. In dbt, you define something that you are not transforming, that you are not, is not the result of a dbt model, you define as a source. So if you read from landing table, generally you have a source that is pointing to that. Then you can decide a simple way. Okay, I want all columns with their names. If that's work for you because you already have good names in your files, that's great. If you don't, like often, I prefer to say, okay, don't get them. I will just list all the columns that I want so that I can rename. I can do all the small changes that I need. And you see, you can also filter. And in this case, I know that the header columns, they will have in the client account ID, they will have the text client account ID. So that's a very simple way for me to remove the headers. And here you see, in some cases, you just provide what is going to be the new name and, of course, the old name. So it's going to be old name as new name. If you want some static text, I adopted the same syntax that, for example, you see with the data vault. So the old data vault now with the library that Neil dbt vault has provided so kindly to the community. And then you see you can just put a piece of SQL. So if you client account code, you want to don't show all the code, just part of it, for example, so that only that part is going to be stored in your history table. So that's, for example, could be one way to handle GDPR things. So PII, you somehow mask here, but you still have the ability to get there from an alternate path that you can control better or distribute to only the people that need to access that. And of course, in some other cases, I cast to number what need to be enough. Then you define, very simple way, the different hash keys, primary key, foreign keys. If you know data vault, you already know what you're talking about. If you don't know data vault, an H key is the primary key, is the definition of the identity of one entity. And you see, in this case, there is, of course, one that is the position H key, that is the key for the major entity that we are storing. And then there's some foreign key that this entity is referencing. And then the HDIF. And HDIF defines what columns contribute to a new version. Last but not least, you just call the macro. You call the stage macro, and pretty much this is what you get. This same you can do with very simple, very structured SQL. So the choice is yours. I can show you a version in SQL later so that they all compile to the same thing in the end. So you can choose, this one is easier to read, the other one is probably easier to understand for SQL hardened people. History, even simpler. As I said, after you have defined the H key and the HDIF, there is not much to decide. So the only needed input is where are you reading from? So the staging model, the H key and HDIF, because you need the identity and the HDIF for a change in version. Then there are other potential inputs that helps you either, like we said, if you want to ingest multiple versions in the same round, you need to be able to order them. So you need a sort to be able to order if you get multiple version changes in the same ingestion round so that you can put in a consistent order. And then there are other fields that help you with improving the performance. So you can have these high watermark so that you don't reprocess all the data every time, but just what is new. So this is important because when you have a lot of data, it's really important. In some other cases, maybe it's not so much important. And last but not least, a nice utility, because in the end, the goal is what I said earlier. So if you have easy way of using your data, everything becomes easy. So we should really help the people that work on the data platform to concentrate on building the difficult part, the business rule, the data marts, not in building the infrastructure, the known pieces. And so you see, again, very simple. You just call a simple macro, and then you get which one is the current version, is current. It's just nice Boolean, so you can very easily filter where is current, and reads perfectly like English. You get which number version is out of how many version you have for that specific item. And then the validity range from to, and this stable, slowly changing dimension key. This is most important for dimensions because you want to use that in a fact. If you want to point, if you're going to use a slowly changing dimension and you want to point how was this entity at the moment of the fact. That is a stable relation that you can use downstream when you go into the data. So this is, I think that I hope I made clear enough how this is a solved problem. It's not a problem how I do, it's just a problem. I want to use these macros, I want to code mine, I want to use data vault, but the knowledge is only the knowledge that you need to have is about what is the primary key, what is the HDIF is pretty much all the columns except the metadata. So you need just to know your data to be able to ingest them nicely nowadays. And also for ingestion, there is where is the file, what is the name of the file, what is the name of the landing table, and the columns that are in the file. So it can almost be generated. And I say almost because I prefer to have a human to actually press the button and say, okay, this is how I want it. But I have a project where they have generated 450 of this pipeline because they had to ingest 450 tables from a source system. and it works perfectly fine. I just prefer that we go one by one because then you need to know, you need to make the choice of how to make the data usable. That is something that you can't really automate. Now, if we get to where the actual important part is how we can improve then the rest of the data platform where 99% of our time is spent, because this one, ingesting and storing the history, should just take 5%, 10%. And that amount of time is if you don't know exactly what are the objects that you are ingesting. So you need to figure out the keys, you need to figure out how to make the data usable, how to convert the timestamps. But out of that, not a lot of complexity there. Now, when we actually come to build and move from, okay, we have the data, now let's build the information, how can we go about it? In this example, it's very generic. Don't look at this lineage as it would be a real thing. It's just trying to give you an idea. So if we have one, two, or a few systems that have been already pretty much integrated, so, and that I mean that they have the same codes, because often when in a company, in a department, they are using one, two, or three systems, they already have done some effort so that they share the same code. So you can probably get those systems, ingest them, and then they can already be very easily integrated. And this I would call it's a base domain. It's the base unit where you can just take the data from this system and you can easily join them together. And it's important also to recognize what are you doing. So with dbt, you will build models, and this model have to be in a directed acyclic graph. So it's a graph that does not have loops. So it means that you have to transform one step after the others so that you go from the raw data into the improved, refined data. And when you do that, you have operation that you will repeat. You have logical steps. In this case, I put a TMP, a temporary. So it's a temporary model. It's something that you don't want anyone else to depend on. It's an intermediate calculation that you do because either you want to add some tests, because you want to verify with some external data that you are doing the things right, or that it just too complicated for performance reason. Also, you want to split it there so that this intermediate result can be used. But it's not something that you want anyone else to depend. It's almost like a private thing. Then you have other models where you have put together a good business concept. And this is something that you want to publish as, okay, this is good to be reused. This is something that it's fine because it's the standard customer or the standard product or the standard product for Italy. Because maybe you have the product for Italy, and then you have the product for Finland, and the product for UK, and they are not exactly the same thing. And you can see here, for example, they might have maybe not the product, but other things, or maybe even the product, because maybe in Italy, we don't distinguish between colors. In the UK and Finland, they actually have a different version. And so you want to aggregate. And this is another thing. When you have different granularities, a common thing is that you have some aggregation. But it's important if it's the atomic granularity, it's a ref, or it's an aggregated, let's say, product, invoice, whatever entity. So because then the people, your colleagues and yourself after 3 or 6 months, you will not remember if you have new names every time. So this is the first step that I'm saying. So try to figure out what are the common steps that you are doing, the common logical thing, and get some consistent prefix. In this case, I think a ref step is good for refined. It's something that people can depend on. AGG stands for aggregate, and it's a refined thing, but not at the lowest granularity. This is already at a different granularity. So if this is not granular enough, you can find something. And in dbt, you have the lineage, so you can easily go back and see where is the finer granularity because it's the ref model that this aggregate depends on. And then you can probably put things together, maybe these three country-specific entities, and make the European specific entity. Because every entity in each country maybe has a little bit of fields that are different, but European have to be the kind of not average, but the mix of them. So you can only have the data that you have in all three components, or you will have something that is pretty much full of nulls. But whatever it is not the same. And it's good to be able to say, so for example, another thing that is important when you build names is to try to give also the context. So it could be ref ITA for Italy, ref UK, ref whatever, so that you explain if this is not the customer, the product, this entity in general, it is in this context. And again, it's like a pyramid. You can start from the simple entities that you can build from the data that you have, and then you join them either similar entities or different entities. Maybe you have products and sales and you put them together and you build like a pyramid. And this is what is also this kind of graph going to show. And by this, you refine from the simple data that you get, the raw source data, into better usable information. And of course, then at the end, you will also have your delivery layer. For example, this is a real case from a customer. And if you also good long name, of course, I have made the names not readable so that to keep more privacy, even if I've been allowed to share it, but still, I prefer to share only what is important. In this iteration, I was still using TR instead of TMP, intermediate transformation. I think that TMP is easier. Then sometimes we also have other things. In this case, we had mapping table. So we need to map from one system to the master data system, some codes. And then now I would call them MDD, in this case, MDM, where master data dimensions, because we need some data from master data, in this case, because we had some code conversions that we need to use. And so you see, when you read something like that, and you know, because you have agreed this code, and you also have a name, map warehouse to factory, it's pretty much easy to read. You don't need to open the code and understand everything every time. So this is, I think, one of the most important things, especially in the refined layer, so, where you will have a lot of steps, where you will have to put together the data by doing a lot of joins, a lot of steps. It's really this trying to not mislead your colleague, make it easy for them to understand. I call it the least surprise principle. If do a naming, put it in a place, and in a way that nobody will be surprised. So if your colleague is surprised from the content, then there is something that is wrong, because it will be misled, because you can't read all the source code all the time. You have to rely on the names. And so, okay, but we have 1, 2 systems in real platform. You have dozens of systems. How do we do? Well, we have some base domains that we have built, and you can already have very good analytics out of this. You can have operational analytics. You can already have important analytics from the few already pretty much integrated system in a department. But of course, you need to then build a bigger thing. And this is simple to do. Again, it's a bigger level of this pyramid. So you get the data that you have refined in one domain. At this point, you probably need some master data mappings. You might also need some master data dimensions. And you put them together, and you pretty much have that if we think this is, I call domain 1, 2, or 3, but if we think in DBT way of thinking, might be project one, this might be project two, this might be a project three where you have the master data, and then this might be project four where you're building the company level refined layer. And so while here you don't get all or most of your input from source data, you might get it from refined data that has been refined in the previous step. You can call it data mesh. You can call it whatever you want. You just divide it in pair. Honestly, I don't really care how we call it. I think that the concept is really important, that if you apply good software engineering, so you have built something that can encapsulate a lot of logic, and you don't need to expose everything to everybody. You just decide, and you can use a data mart to put there all the dependency that you want to expose, all the data, but you don't need, if you have a customer typically has 100, 200 columns, you want to always expose that to everybody? Probably not. So you can decide which columns of your customer, of your product, you want to make available down the line. You can put it in this data mart because then you can have good data contracts. What are the columns that are there? What are the data types? Some tests that guarantee what is there. And then, of course, you can also have good API-like versioning. You have my product V1 and my customer V1, and you have in dbt, with the dbt mesh, you have this ability to, okay, at some point I introduce version 2, and who is reading the data down the line, the company project, they will have, you can provide them some time to switch from version 1 to version 2, because that is important. People in a big company, they're not just waiting us to do our changes and react immediately. You need to be able to put this separation layer, these evolution paths that allow people to react with the time they have. And so this is, I think it's very simple because it's just a data mart. In dbt, you can create a data mart by just making a folder, and in the dbt configuration, making that created in a different schema. So you create a data mart that is delivered in a different schema. You have a role that gives access to that schema. And so with a very simple way of doing, you are creating a very good container that you can govern very well. You can govern the access, you can govern what you are delivering there, you can govern its evolution. So it's a very good interface that you can control to make the data available to a downstream client or project. In the end, who's going to read is just the consumer of your data. And of course, you can compose this at multiple levels. And this, in general, the better it goes along with the company organization, the better it is, to the point that probably the first base domain, they are really close to the people that maintain the source systems. Ideally, in a company, you could have that the same team that maintains the source system is also responsible to make the data available to the rest of the company. And in the simplest form, you can just have the base domain, the basic level of the base domain is just the ingested. So this var model or the history models, so that it's ingested only once for all the company. It is ingested in the right way, with the right keys, with common names that everybody can depend on. And this is done only once by the people who know them. So I think that that is already a good step, because that's one of the biggest things that I get from our customer. They have a lot of data, a lot of people want to use it in the company, and everybody is just in a wild west getting data out of data lakes. Nobody knows what is using, or on the other side, to avoid that, they are not allowed to get the data. So that is, for my presentation, the original presentation I did in London. Today, I just make it a little bit more discursive, talk a little bit more. And this is the summary. Ingestion and storage, to me, it's solved. Pick the way you like, but make it so that it's simple, easy to maintain, and your people will not have problem to use it. Use this modular business concept refinement style if you can. Just build one step at a time, have clear name, clear role for your models, and design for readability, reusability. Avoid these dependency loops. With dbt, you have to. If you don't use dbt still, you can do it. It's a good thing. It also makes it much easier to recreate your data. And then, of course, if it makes sense in your case, split the projects in a way that a different team can easily collaborate to good interfaces. And then what I've tried and why I call it pragmatic. So I tried to get only what was useful in the different projects that I've been working on. And at the end, this is what I put together. So trying to use very simple tools, pretty much very simple SQL, a very simple pattern that everybody that knows SQL can understand, can immediately start collaborating on. And unfortunately, Data Vault has a quite high learning curve. So this is what I found that many times has been the problem with Data Vault. So, and what I'm trying is mostly to provide a very simple way of doing it. So thank you very much. And this is what I had to say. So now I'm very happy to get comments, questions. So
thank you very much, Roberto. That's great. We are had a lot of traffic on the chat. Probably read out a couple of the questions from there and go from there. I think question here is DBT an ultimate tool for data engineering? I think you know the answer for that one.
Well, if you ask me, I would say yes, but not because I get paid from DBT. So consider, I wrote a book. I'm going to write another book on DBT. I have a lot of Snowflake stuff. I just have a polo. Actually, no. What is this? How do you call this one, Neil?
Sorry,
Yeah, a sweater. So a sweater from from DBT. So it's not very much. So I'm not paid at all. I just love a product that allows me to do what I think is the best way for now to do data engineering, like it is the best way for now to do software engineering, because to me, in the end, they are not really different.
Yep. Question about how you may handle real-time data coming in, streaming data.
Well, I think that the best way to do it, so if you really need real time, and I mean under 1 or few seconds, well, Snowflake dbt is probably not the perfect stack for you. But if you are in the 5 minute, maybe 1 minute, definitely 15 minute, near real time, then a Lambda architecture works pretty well with both dbt and Snowflake. So in that sense, and also by doing the ingestion in this way, where you control the ingestion, because you are going to call the copy in to get the data in, you will have a clear timestamp that you put when this, that's why I said ingestion timestamp is so important, because that's what you are going to use and put in your Lambda architecture every time that you rerun, so that what is batched before this timestamp, and what is in real time is going to be in the transformation layer to the views. Yep. And you can also use ephemeral models to actually avoid duplicating the code between the batch and the real time parts.
I would agree. We find exactly the same thing as you do there. It's great for that short time frame, that short time frame load. But DBT takes time when you run it to build the DAG up and so on, and therefore you can't get it to run in very short time frames. But
yeah, I would say 5 minutes. No problem. Okay.
Yeah.
15 minutes, perfect. 1 minute, try it. I'm gonna be scared run it every minute. Yeah. Not because of the cost, because if you need to, you need to, but because if something goes wrong, having two runs that overlap is not great.
That's true. Okay, right. We've run out of time. So thank you, Roberto. That's been very interesting. We've had a great turnout today, and hopefully everyone's really enjoyed what you've had to say. Of course, we would add that Data Vault is an option in the mix as well for certain aspects of it, and it can be very useful for the central team to have a slightly richer way of modeling I think in there.
Definitely, and
It doesn't matter.
and I made very clear. So to me, one or the other, they both solve the problem. Data Vault provides probably a more open-ended solution that is longer lived. In this way, you will, if you have some changes, you will have to do some adaptation. But I would say that 80% of the advantages you still get similar, but without having to train a lot of people. So in that sense, I think it's the closest thing that you can get without this high ramp.
I fully agree with you. Yes, if you're doing a distributed set of teams, you can't bring everyone up to an advanced level, so you have to have simpler solutions in the mix. I agree.